Hello guys, in this video we are going to review how to calculate the frequency or wavelengths of light. We know that light is electromagnetic radiation which travels in waves. In a vacuum it actually has a constant speed which is 3 times 10 to the 8th meter per second. And the speed of light is connected to the frequency and the wavelengths. The wavelengths is the distance over which the wave's shape repeats. So for example, if we have this wave down here, we start right here and the shape repeats up to this point. So the distance between these 2 points is going to be the wavelengths. And the frequency is the measure how often the waves repeat per unit of time. So if this time here is, let's say, 1 second, then our wave repeats 1, 2, 3, 4 times. So our frequency is going to be 4 1/2 or 4 second on the minus first, which is also 4 hertz. These are all the same units, just shown differently. So 1 hertz equals to 1/2. I hope this makes sense. So let's jump right into the examples. What is the frequency of the electromagnetic radiation that has a wavelength of 1.8 meters? We are going to use this expression and solve for the frequency first. So the frequency equals the speed of light divided by the wavelengths, and now we just simply plug in the numbers. So we know that the speed of light is a constant, 3.00 times 10 to the 8th meter per second, divided by our wavelengths, 1.8 meters. If you do this calculation, you are going to get 1.7 times 10 to the 8th. And what is the unit? The meters cancel out. 1/2 or second on the minus first. Okay, I hope this makes sense. It's pretty simple. Let's do the same thing for the wavelength. So what is the wavelength in meters of electromagnetic radiation that has a frequency of 9.7 times 10 to the 7th second on the minus first? So now we are going to solve using the same formula for the wavelengths. So from here, the wavelengths equals to the speed of light divided by the frequency. And the speed of light again is a constant, 3.00 times 10 to the 8th meters per second, and divided by the frequency, which is 9.7 times 10 to the 7th 1/2. If you do this calculation, you are going to get 3.1, and let's double check the units. So the 1/2 will cancel out, so we are going to have meters. In some of the questions, you are going to see that the wavelength has to be calculated in millimeters, nanometers, or any other unit. So don't forget to double check your units to get the correct answer. All right, I hope this makes sense. See you in the next video.